x even. Expand 1 plus x to the third in ascending powers of x up to and including the term in x squared. So quite kindly they started off with one that does have a 1 at the start of the bracket, and this should be quite an easy couple of marks, shouldn't it? 1 plus x to the third, copying it straight from that formula, so it was 1 at the start plus n times x, so that's a third times x, plus n times n minus 1, so a third times a third minus 1, and I've just said this is that place to be really careful, it's minus 2/3, isn't it? Over 2 times x squared, and that was as far as they wanted us to go. And when they want you to expand it, they will insist on this being fully simplified in order to get all the marks. It's not enough just to write it like that. But you can use your calculator, which should deal with the fractions all right for doing this. What would we get? We get a minus, and the 2 will cancel out, so it would be minus a ninth, I think. Is that right? X squared, and then it will go on. That's quite a nice 2 marks, isn't it? But then we've got, hence or otherwise, expand 8 plus 16x to the third. Have you noticed, if you've been doing past papers, they almost always do this, don't they? There's always an expansion and then a kind of hence bit. And it'll either be tweaking it slightly, or it might be changing the x term into, have you noticed quite a common one where they change the x into something like y squared plus 3y or something like that in there. Or there's one where they then multiply it by something else, and they're all quite common second stages. This time we've got 8 plus 16x to the third, which is supposed to do to the same number of powers. So while checking this through, we've got 8 at the start, so we need to take a factor of 8 out. It becomes 8 lots of 1 plus 2x, all to the third. The third applies to both bits, doesn't it? So that's 8 to the third times 1 plus 2x to the third. And now we get the hence part of this. So 8 to the third is 2. And this is the same expansion that we've just done up here, but we need to replace x with 2x. So this is 1 plus a third of 2x minus a ninth of 2x squared. And then it will go on. And so we've got 2 lots of, what have we got? 1 plus 2/3 of x. And remember, we've got the same thing going on in here, that the 2x would need to be squared, so it's 4x squared, so that's 4/9 of x squared. So it looks like that. Oh, are you alright, Alice? Have I made a mistake?
No, it's right. Earlier you put x has got to be between -1 and 4.
Yes, x does. Okay, so this is, right, so these expansions, this is valid if the x value that you put in is between -1 and +1. And this one, it's not the coefficient of x we're talking about, it's x. So this is valid as long as the x term that we're putting into our expansion is actually this x bit is between -1 and +1. So I don't know, it's about to ask us about it now. So this expansion, when it says state the values of x which is valid, it's whatever you've inputted into your binomial expansion needs to be between -1 and +1. So here, the binomial expansion bit, we did 1 plus 2x. So this is valid so long as 2x is between -1 and +1. Okay, so that gives us x between -1/2 and +1/2. Okay, now remember it's not what the coefficient of x is here. So the fact that this is 16 and way outside the bounds of -1 + 1 is not the important bit. It's whatever we put into the binomial expansion, whatever we get there when we do the 1 plus bit, that term has got to be between -1 and +1. Okay. It simply means that if you subbed in x equals 3 into this expansion here, then what you would get is a divergent sequence, and the bit that we've done of it would in no way resemble the final value of what it's equal to. It would be enormous, would be the total value, that would be infinite. If you kind of did the expansion forever, and it wouldn't converge to a proper value, because this simply would not equal what we started with. Okay, is that all right? That's fine.